Hey guys, today we're starting chapter 11. We're moving on from 0.8. We're starting chapter 11 and this is day 1. We're going to continue with statistics, so we're going to put to use all of the stuff that we learned before. Some might seem like a review, but we're actually going a little bit deeper. Okay, so what we've learned so far is we've discussed different ways to describe the center and the spread of the data, right? We learned about mean and median, and these describe the center of the data. We learned about standard deviation and 5-number summary, and those described how spread apart the data was. Today we're going to start talking about distributions. Distributions describe the center and the spread of one variable data. We call that univariate. What does one variable data mean? Basically, it's everything that we've been doing right now. All we've been doing is, okay, so like these are the goals, for a season. This is the number of wins of the Super Bowl game. So that's one thing. We're not looking at, this was the number of goals that were scored versus another variable like the temperature or the humidity in the air or whatever, right? So we've been doing one variable data. All right. When you do a distribution, you basically make a plot of the data and then you look at the shape of it. One such plot is the histogram that we've been doing. To best describe center and spread, what we have to do is first identify the shape of the distribution, right? And so once you've done a histogram, you can see that on the histograms that we've done, not all histograms look the same. Here are 3 common shapes of a distribution, right? Again, a distribution is is a graphical representation. So take a look here. We have symmetric and skewed distributions. So look at this first one here. Do you see how this is not symmetric? If we draw the histogram and then on top of it, if we draw a curve like this, right, that connects the vertices, you see that very clearly it's not symmetric. In fact, there is a part here that it sort of like trails off. We call that the tail of the distribution. And you can see here the tail of the distribution is on the left-hand side. So this is called a negatively skewed distribution or a left skewed distribution. Negative because the tail is on the side of the negative numbers. It can be a little bit counterintuitive. Even adults sort of say, oh, the peak is on the right, so it's a right distribution. No, we don't go with the peak, we go with the tail, okay? Even math teachers sometimes, have to think twice about this. But you have to focus on where it trails off, where the tail is. You see in the second one, when you draw the curve, look at how nice and symmetric this is, right? That is, there's not much to say. It's a symmetrical distribution. The other one to the third one now, again, there is a trailing off that happens and the tail is here. This time the tail is on the opposite side. It's on the right-hand side. So we say this is a positively skewed or a right skewed distribution. Now, let's take a look at it a little bit more closely. Let's look at the symmetrical distribution. In the symmetrical distribution, look at where the mean is and look at where the median is. They are very, very close to each other, if not the same value. So that's one thing about a symmetrical distribution, is that the mean and the median are very close together. Now, in a skewed distribution, the mean is closer to the tail than the median is. So let's take a look at our negatively skewed distribution. The tail was on the left-hand side, right? And look at the mean. The mean is closer on the side of the tail. On the other one, for the positive skewed distribution, the mean is now on the opposite side. You see how they switched? That's sort of part of why it's a right or left distribution. So always remember that the mean is on the side of the tail. Okay. Now, Let's talk about median. Median was the center value, right? The central value. Okay. Now, suppose I have a series of quiz scores, right? And I have an outlier in there. So suppose my quiz scores are, I don't know, 17, 18, 18, 19, and then I have a 5, right? So whether that lower, okay, so where is the median for this data? This is the median. Okay, now look at this 5, that's an outlier, right? But whether I had an outlier or not, so whether that small number, the smallest, the lowest score, whether it was a 5 or a 15, would that have changed the position of the median? No. That's why we say the median is less affected by the presence of outliers, right? We call that a resistant statistic because it resists that outlier, okay? The mean, however, is more affected by outliers. So look at that, that same data of the quiz scores. Think about what the average of those quiz scores are, and then think about what would have been the average had that lowest number been a 5, right? If it's a 5, do I get the same average of the quiz scores? Do I get the same mean of the quiz scores versus if it was a 15? Absolutely not. So the mean is definitely affected by outliers, and it is called a non-resistant statistic. Okay. What about standard deviation? Well, standard deviation talks about how spread out your data is. So again, think about it. Think about if I have this 5 in there, and then so my data now is spread out from 5 all the way to 19, versus if that was a 15, is it as spread out? No, it's not. So because an outlier will affect the standard deviation, again, it is a non-resistant statistic. Okay, now, why do we care about this stuff? Well, the reason why we care about this stuff is because most of the time, when we do statistics, we're not just looking at 5 quiz scores. We're looking at, okay, we polled the nation and we're looking at the approval ratings of candidate A versus candidate B. How many people are in this nation? A lot more than 5, right? And so when you look at, the macro of it all, not all data is going to look the same. There's going to be a lot of variation in the data. And so, a poll on candidates might look very different from a poll on climate control, might look very different from a poll on who likes sesame buns on their burger and who doesn't. And so each set of data will call for a different way to represent it and to analyze it. So that's what we're looking at today. All right. So how do you choose to describe your data? Are you going to use median to describe it? Are you going to use standard deviation and mean to describe it? Well, here's how you tell. You first have to examine the shape of the distribution. So now, if the distribution is symmetrical and free of outliers, then you have to use the mean and the standard deviation. If the distribution is skewed or has strong outliers, then you have to use the 5-number summary, which includes, minimum, median, and so on. All right, so that's how we're gonna do it. So you have to look at the shape. Symmetrical, use the mean and standard deviation. Skewed, use the median. Okay, so here we go. Here we have the laboratory grades of students in a biology class. It says construct a histogram using your calculator and use it to describe the shape of the distribution. So first what we're going to do is we're going to put this in our calculator, and wouldn't you know it, I already have it right here. So you see here I went down 72, 86, 68, 92 all the way. There is, this is a set of 24 data. And so what I've already done is gone up here to the heading, and I've labeled it grades. Okay, now I'm going to create a histogram. So what I'm going to do is this. Control, and I like that these are being recorded so you can always go back. So Control and add a page here, right? The doc window, add a page. And now it says, what kind of page do you want to add? Well, we want to do some data and statistics. Here we go. Okay, that's all the data. Now, click at the bottom here where it says click to add variable. If you just click, it gives you an option. The only option we have in there is grades. So click on the grades, and there we go. It sorts the grades for you. Now I want a histogram of this. Well, in order to do the histogram, I need to look at the min and the max of the data. And it just so happens that the min is 63 and the max is 98. So when I do my histogram, I'm going to go, to the lower whole number here, or I'm sorry, to the lower multiple of 5. So I'm going to make my histogram, I'm going to make my scale go from 60 to 100. Okay? And then I think I might want to go by 5s, right? I'm going to have classes of width 5. Okay, so here's what we're going to do. Here, it's going to go 60 to 64, 65 to 69, 70 to 74, 75 to 79, 80 to 84, 85 to 89, 90 to 94, 95 to 99, and that's good enough. So this is where we're going to end. Okay, let's go back. Let's go back here. Remember how I had sorted this? I'm going to go to menu, and I'm going to say I want my plot type to be number 3, a histogram. And there we go. Okay, that's a histogram, but that's not the histogram that I want. So I'm going to go back to menu, and I'm going to play around with the settings a little bit. First of all, let's go to window and do window settings first. I want my X min, right? I want to go from 60 to 64. I'm sorry, to 100. And then the Y max, I don't know. I think we might have more than 3 bar, like, more than a height more than 3. So why don't we just go to, I don't know, 10. Okay, enter. All right. Now go back to menu, plot properties, histogram properties, and number 2, bin settings. I want my bin settings to have equal bin width. I want the width to be 5, right? From 60 to 64. The alignment, let's make the first one 60. Press OK. Okay, look at that. That's what it looks like, right? Isn't that beautiful? And now when you look here at each of the points, look at this one. This first one is, now it says when I hover on here, it says it goes from 60 to 65. Now we know that's a width of 5, right? I'm sorry, that's a width of 6. So you should know that that's the one that goes from 60 to 64. Because look at this, in our histogram, we don't repeat the values. So we go from 60 to 64, and then we start at 65. But if you look at this, the first one goes to 65, the next one starts at 65. So always make sure that the second point is 1 lower. So it's 60 to 64, and we have 1 point there. So let's do this axis. We have 1 point, and then if you go to the next one, you have 2. Isn't that beautiful? And then if you go to the next one, if you hover over the next one, you have 3. So I'm just hovering. It shows you everything. My pen, my stylus is not aligning with those lines. Make sure you make them nice and neat there. Next one, I have 4. Next one, from 80 to 85, or 80, 84, I have 5. And then I have 4, 3, and 2. So 4, 1, 2, 3, and 2. All right, so that's my histogram. Right? And you can see how easy that was, and so on. All right, so let's describe the shape of this distribution. Okay, so this looks pretty symmetric to me, right? It's never going to be perfect, but this is pretty darn good. All right, now summarize the center and spread of the data using either the mean or the standard deviation or the 5-number summary. So basically it's saying, what are you going to use to describe this? Well, because all you have to say is because this is symmetric, then, right, what did we say here? Because it's symmetric, we're going to use the mean and the standard deviation. So we say, since it's symmetric, we use the mean and the standard deviation. And what is the mean and the standard deviation? Well, we have the data in our calculator, right? It was in the next tab to the, it was in the tab to the left. So I just go over there and I do same thing as I've always been doing. Statistics, stats calculations, one variable stats. And here we go. The standard deviation is 9.5 and the mean is 81.25. Okay, so there you have it. All right, that's all for today. You can go ahead and do the homework. Thank you so much.